Welcome to the third and final part of Chapter 1, or Module 1. Today we're going to be talking about collecting sample data. And one of the things that we really need to keep in mind when we're collecting data is that we all have our own biases. And it's really important that you learn what your biases are in one direction or another, and to make sure that if you are doing an experiment that it doesn't accidentally introduce itself into the experiment as you do that. And let's just jump into it. So statistical methods are driven by the data that we collect. We typically obtain data from two distinct sources, and here are our definitions. This first one is an observational study. Let me make that a little small there. In an observational study, we observe and measure specific characteristics, but we do not attempt to modify the subjects being studied. In an experiment, we apply some treatment and then proceed to observe its effects on the subjects. So this is an experiment. We often use the word experiment when sometimes we actually mean an observational study. Let me kind of give you the difference between these. An observational study, so picture you're in a classroom, and in the classroom, to do an observational study, what I could do is I could put cameras up, and I want to do a study who uses their cell phone during class more often, men or women. And so the whole idea is you don't know in the class that you're being observed, and we want it that way, because if you knew, then your behavior would change. You would use your cell phone less, most likely. In an experiment, that means that we're actually doing something. So one group of people gets what's called a placebo in an experiment, and the other group does not, and no one knows if they're getting the real medicine or if they're not, type thing. So we're actually comparing two groups to do that. That's what an experiment is. And let's practice a little bit just to make sure we got that. So a marketing firm does a survey to find out how many people use a product. If the 100 people contacted, 15 said that they used the product. So in that case, that's definitely not an experiment, that's an observational study. Because we're not comparing two groups of people, we're just gathering information. Number 2, a clinic gives a drug to a group of 10 patients and a placebo to another group of 10 patients to find out if the drug has an effect on the patient's illness. I kind of gave this one away earlier. This is definitely an experiment. Two groups that you're comparing. Next up, a sample of fish is taken from a lake to observe the effect of pollution from a nearby factory on the fish. You might think this is an experiment, but this is actually an observational study. Now, if they said that they picked up some of the fish and they put medicine on one side of the lake and non-medicine on the other side of the lake to see the traveling of the fish, things like that, that would be an experiment. A quality control specialist compares the output from a machine with a new lubricant to the output of a machine with the old lubricant. This is classic experiment. You may want to go through those again for the practice, just to kind of make sure you have it down. Moving on, we have a few more definitions here. Like I said, chapter 1 is mostly definitions. And these are proper sampling techniques. In fact, we run into a few improper ones as we're looking at this. We're going to start with a random sample. This is ideal. So this is members from a population are selected in such a way that each individual member in the population has an equal chance of being selected. This would be as if I'm in a class with my students. I assign a number to all the students. They write the number on a small piece of paper. I shake it up in a bag and I reach in and grab one. Everybody equally likely has a chance of being chosen. Next up, we have systematic. In systematic sampling, we select some starting point and then select every kth element in the population. Let me explain what that means. So let's say that I have students in my classroom, and I start with one student, and I want to select every 5th student to help me with some sort of demonstration. So I start with the first one, 1, 2, 3, 4, 5, there's another one who's going to be part of it. 6, 7, 8, 9, 10, there's another one. So every fifth person in that case, or every kth person in that population. This can be good as well. Again, ideally it's random, but that's not always possible. So that's why we have some other ones also. Next up, we have a bad one. This is called convenience. Sampling. Convenient sampling, we simply use results that are easy to get. So for example, when I keep saying I want to gather data in my classroom, that's convenient sampling. It's also called lazy sampling. My students are already there. It's easy to get the data. I don't have to go out and do a random sample or a systematic sampling. Again, this is not a very good way of doing it, especially something like a classroom where it's a night class, so that tends to be people that are professionals working all day that tend to take the night classes and so on, and it could skew results and things like that. So this is a bad way. And we'll talk about more bad ways here in just a second. Number 6, we have stratified. This is where we subdivide the population into at least 2 different subgroups, strata, and so that the subjects within the same subgroup share the same characteristics. Then draw a sample from each subgroup or stratum. Before I explain what that means, I want to do the next one and then compare the two, because these two are actually easy to mix up. Cluster sampling, we first divide the population into sections or clusters, then randomly select some of those clusters, and then choose all the members to do that. So let me show you the difference. Let's say that I'm in my classroom again, and on one wall I want all of the teenagers to go, the other wall all the 20-year-olds go, another wall the 30-year-olds, and the fourth wall will be anyone 40 and older. Now, they have been stratified, or they've been broken up into meaningful groups, meaning there's a purpose that a person is in one group versus another. Then what I would do is I would draw a sample from each of those groups to make sure that I get some teenagers, some 20-year-olds, some 30-year-olds, and some people that are older than their 30s. So these are groups broken up by purpose, meaning there's a reason that one person is in one group and not in the other group. And then some are drawn from each group. This is often done in college committees and subcommittees, as they'll say that we need at least 2 math teachers and 2 English teachers and 2 psychology teachers and 2 counselors. That would be a form of stratified sampling. Cluster sampling is a little different. Cluster sampling would be we divide up the population with no purpose. Meaning, if I'm in my classroom, each row would be a cluster. So there's no reason one student couldn't be in one group or the other. And then what we would do is select a few rows or a few of those clusters, and then we would gather information from everybody in those clusters. We'll do some examples of that here in a few minutes. But these two, again, are a little bit easy to get mixed up. So you may want to go back and go through these definitions again with me, just by going back in the video a little. Next up, quick note, here are some non-probability samples, meaning this is bad ways of drawing data. Bad. Purposive or judgmental. So let me give you an example. Let's say that I want to do a study, does the population in Long Beach, what % of them believe in God? And so I go to a church, and I go to a mosque, and I go to a Jewish synagogue, and I go to a Buddhist temple and ask, do you believe in God? I'm obviously trying to get, I have a purpose, I'm trying to make do. Or the other side of that would be, I go to an atheist convention and I ask if they believe in God. And that obviously means that I'm offering a huge bias into this if I sample that way. So we, of course, definitely want to make sure we avoid that altogether. Convenience sampling, we already talked about. That, again, would be if I just use my classroom to be a sample to represent all of any given college. The third one is on the back. is the quota. A quota is a minimum or a maximum that is put onto a situation. So a common one, this isn't how the police work, is you get pulled over and you think to yourself, he hasn't hit his quota yet, or she hasn't hit her quota yet, meaning implying that they have a minimum of pulling people over and giving tickets. Again, that's not a very good example. It's just one that comes to mind. But what this does is, if I have a minimum, like I need to sell a minimum number of tickets to a group of people, I might be tempted to start lying about what the ticket was for, or embellishing what you could do with the ticket and things like that. So you can see that this is definitely not a good way of doing that. Let's practice a little bit, make sure we have this down. All right, so this is going to take a little bit of time. So we're going to figure out which method of research, of sampling, is being offered here. So we'll start with the first one. An ecologist uses the line transect method by stretching a rope across a lake and collecting samples at every interval of 5 meters. Well, if you flip back in your notes and you read through it, this is that systematic sampling. It's systematic because it's every 5 meters. This is like what we talked about before, where I got every 5th student or something to that effect. Systematic sampling. Next up. To determine her stress level, Hannah divides her day into 3 parts: morning, afternoon, and evening. She then measures her stress level at 2 randomly selected times during each part of the day. That one is stratified. Now, they're broken into meaningful groups. And then just a few are sampled, meaning time periods. So 2 times in the morning, 2 times in the afternoon, 2 times in the evening. So all 3 get a sample taken from them. Next up, a survey is conducted by randomly selecting 7 schools in an area and interviewing all the teachers at each school. Meaning there are more than 7 schools, but 7 schools are selected and everybody, all the teachers, are interviewed. This is cluster. So here's a good solid 2 examples of the difference between stratified, broken up into meaningful groups, and then some from each group are looked at, versus cluster, where 7 schools are there. There's really no meaning. They're just 7 random schools are selected, and then all the teachers at that school are interviewed. Next up, a researcher interviews the first 20 patients who enter a clinic with arthritis. This is definitely convenience. Right, the first 20 that come in, come on. A researcher is examining coffee prices in New York. First random numbers are assigned to each shop, and then every 4th shop is chosen from the list. This is classic systematic. Researchers are attempting to determine the average height of trees in a park. The number of trees in the park have been tallied, and there are 400 trees of various sizes. I'm going to summarize this a little bit. Each of the 400 trees enter into a list in the computer, including information, variety, location of the trees. This list is then randomized. There's our key. So this is not in any order, and arbitrary numbers would be assigned to each tree. That's, again, what we're looking. The researchers or computer program then selects at random, without bias, a selection of trees from these meaningless numbers. All right, this is definitely random. You may want to read through that one again and see the parts that by the way, just because the word random is in there does not mean that it's going to be random selection. A target population in a study is church members in the United States. There is no list of all church members in the country. The researcher creates a list of churches in the United States, then chooses a random sample of churches, and then obtains lists of members from those churches. This one's a little wishy-washy. We could say that this one is, the reason why this one's a little tough is because we don't know if they are getting lists of all the members of those churches or not, because it might be clustering, but we're going to call this one random. So again, this one's not worded all that well. All that clearly, I should say. A researcher organizes the population of students in a college by college class, freshman, sophomore, junior, senior, then randomly selects appropriate numbers of freshmen, sophomore, juniors, and seniors. So here they're broken up into meaningful groups, and then some from each group are interviewed. This is stratified. And that concludes our video.